So up first we have Tim Butler from Kinetics, and he'll be talking about Docker and Python. Please welcome him.
Okay, thank you everyone for turning up to my talk. So just to start things off, just wanted to get a rough idea of who's heard of Docker. Okay, pretty much everybody. And who's actually used Docker before? Okay, probably about 50%. And the magic question, who's actually used Docker in production? Just a couple. Okay, for those that don't know me, name's Tim Butler. I'm current enterprise manager for Kinetics. Kinetics is a web hosting and application hosting company, and we've been specialising in container-based hosting for about 10 years now. I've been working with Linux containers for 10 years as well, and been playing around with Python for about 8 years. I've got now sort of 18 months Docker experience and been focusing on it quite heavily over the last 6 months. So at Kinetics, we're actually developing a new product at the moment. So we're combining and working with Linux containers and Docker within those Linux containers. So we're working on a new feature and a new hosting product for the Australian market with that. So just in this talk, I've aimed this talk at newcomers to the technology. So just enough to get you started, get up and running, see what Docker's about and see if it's a good fit for you. So I'll cover just what is Docker, what are containers, go through a few practical examples with Python, go through the downsides of Docker, and also some of the extra services that you may use, and where Docker's heading in the future. So what is Docker? The official definition is an open platform for distributed applications for developers and sysadmins. Essentially, their motto is build, ship, run. So the easiest way I think to think of this is Docker is application containers. So what are containers? Containers are essentially an isolated virtualization layer that's a software level virtualization. So it uses a common kernel, in this case the Linux kernel, and provides you a set of tools to help manage it. So like a VM, you can still start containers, you can set networking on containers, you can set resource limitations and constraints on containers as well. So essentially, Docker is yet another layer of abstraction from standard containers. Docker focuses very heavily on the application layer. So the goal of Docker is essentially to reduce that to a one process, one application container. So the advantages of this is because it's very tightly defined, you get a nice, easy, repeatable deployment from it. So containers, as Tom sort of talked about in his presentation yesterday with the DjangoCon, you want production to be boring. You want it to be safe. Well, what about containers? Are they the latest fad? Is it the new technology? They've in fact introduced 15 years ago into Linux. So there's been quite a lot of work that's been going on with the Linux kernel development, and it started back in the 2.4 kernel era. So for those that remember, that's back in the Pentium 2, Pentium 3s sort of days. And one stat that I always think stands out is Google now launch over 2 billion containers each week. So they spin up, spin down containers for all their services, and they're launching 2 billion each week. So from a production ready point of view, certainly containers are there, and Docker is 99% there as well. So why Docker? What advantages does it offer? It's fast. Docker runs at native speed. Because it's a software level virtualization, you're running at raw server speed. So you're not getting any hypervisor performance hits. It launches in sub-second time. So Docker literally can create and launch a container within 50 milliseconds. It's lightweight. You can have a full Python environment and it's less than 200 megabytes of storage on the disk. But it gets better than that. Docker uses a layered approach to its file system. So it uses a copy-on-write overlay file system by default. What this means is the more instances you spin up doesn't necessarily take up more disk space. There was a company called HipRiot that presented at the 2015 DockerCon, and one of the challenges that they put up was they had 250 running Docker containers with a HTTP daemon inside on a Raspberry Pi. And if you think that's impressive, their aim is 1,000. So it gives you a great little level of isolation. Obviously, the focus, if you're working with microservices, you want to be able to contain those within their own special environment. So for this, you can limit CPU, you can limit memory, you can limit what that system can do. And because it's contained in its own namespace, it can't access the processes from other containers that are running. And Docker makes things easy. Most of the commands are a single command line. It's got a nice REST API that you can also call, and there's quite a number of tools that already integrate with it. So, is it all rainbows and unicorns? Not quite. So what are the downsides of Docker? Or, as I like to sort of refer it to, they're just things you have to be aware of how Docker actually works. The first one, and most of these are both positives and negatives, but the first one is a positive and negative. It's a rapidly changing platform. So the good thing is they're adding new features all the time and improving some of the services that it provides. The downside is you can't just learn Docker once and forever have that knowledge. In turn, that means best practices can go out of date very quickly. Something that was written 18 months ago as the best practice for Docker may not necessarily be relevant today. So you've got to do your homework to make sure that you're actually following what the best practices are. Docker themselves have been working very heavily on their documentation and recently relaunched all their documentation suite. So they're making good inroads, but still have a way to go there as well. Docker containers are immutable. So the moment you spin it up, you can make changes, but as soon as you shut it down, you lose all of those changes. So it takes a bit of thinking sometimes to work out how your services work. Thankfully, they've covered that as well, and they have a concept of data containers, where essentially your data can sit on a separate container to the actual running instance. For example, a database server, you can have your database running in a container and have a data container for the actual database files themselves. Multi-host deployment. So at the moment, Docker's really good at focusing on one VM or one host node and spinning up the containers. The tools still aren't quite mature yet for running it in multi-host environments, where you've got multiple different VMs, multiple different cloud hosting platforms. But they're working on it. And security. This is one that a lot of people get confused on, and because Docker runs in a different way, see this as an issue. Essentially, because you fire up your container and it becomes immutable. So for example, like the OpenSSL bug, there was panic because they've got OpenSSL installed in their container. How do I update it? Well, the answer, mostly with Docker, is that you stop and start the instance. So you can pull down the latest image, stop and start it, and you're a few hundred milliseconds at most to restart that service. So with the OpenSSL bug, you had to restart your Nginx or Apache daemon anyway to pull in the latest changes. So it's not really that much different. You just got to think about it in a different manner. So what are the alternatives to Docker? In the Python world, obviously the virtual environment. So virtualenv is a great little tool to run multiple different versions of libraries and not pollute your dev or production environment with conflicting versions. In fact, one Pythonista I did see described Docker as virtualenv on crack. So the downsides to virtualenv is it's heavily reliant on the underlying system still. So it still needs Python installed on the system, and it's Python only. So when it comes to binary or external modules, like when you've got MySQL and you need some sort of external library to compile it, you can run into some issues there. So you can still face deployment issues. Existing virtualization. So obviously everybody these days is running virtualized system, which is great. Docker isn't a direct replacement for this. In fact, you can augment your VM deployment. Because now you can quite easily and quite efficiently spin up multiple containers within your virtualized environment or virtual machine, you can make full use of your hardware. And you still get all the isolation, you still get the ability to restart. So existing orchestration systems. Obviously, the more tightly coupled Docker is, the more it gives you in terms of configuration management, repeatability, and the orchestration side of things. Again, Docker's not a direct replacement for this. It's integrated now into most of the modern CM systems, so you can actually use Docker still with your existing systems as well. And just plain Linux containers themselves, like Linux containers, LXC, and Virtuoso, which is a product we use. Again, Docker isn't a direct replacement for this. Docker focuses just on the application side of things. So, in fact, you can run Docker within an existing container as well. So you can have this multi-layered system with high levels of efficiency. So, how do we use it for Python? What uses are there for Python? Microservices. Obviously, everybody would love to be able to decouple their dependency libraries for their service into their own little environment. That's great. If you've got lots of VMs you can spin up and manage and bits and pieces, but Docker makes it really trivial to spin up containers and isolate each of those services in there. If you're using the 12-factor app philosophy or sort of following its guidance, Docker is an extremely good fit for this as well. So the configuration management side of things, the troubles that you have between production and development environments. So because Docker is very tightly coupled with your service, you get some configuration management benefits out of this as well. If you've ever had the "it works for me" or "it worked in dev" type problem and didn't realise that you had one little library different between your development and production environment, again, Docker eliminates this for you. Which leads on to repeatability. Deploying Docker anywhere should give you the same experience. So the underlying, whether you're running in Ubuntu, CentOS, running on Azure, running on AWS, it shouldn't matter. And one of the benefits that I've certainly used heavily is essentially use one's containers. So you can spin up a container, spin up, as I'll show shortly, a Python environment, and you can even have it destroy itself as you shut it down. So the overheads to spin up these different environments is extremely low. It's also great for testing. You can run multiple different test environments, spin up the containers, run your tests, and destroy them afterwards. So if you want to run it, one of the good things about Docker is it's not like OpenStack. It's not a complex install to get started. So for Ubuntu, it's just a very simple one-liner. And same again with the CentOS Fedora world. If you're running OS X or running Windows, you can use a product called boot to Docker, which essentially, again, is a one-line script, sets up a virtual environment for you using VirtualBox on your machine. So it takes less than 15 seconds to boot on a modern system, and you can get started right away. Docker also recently bought out the company that produced Kitematic, which essentially gives a nice GUI interface to managing your containers. So how do you use Docker? It's got a very simple command structure. So just as a few examples, you can go run a container, so you go docker run and give it an image name. If you want to restart an instance, you go docker restart container. Listing containers, docker ps. Viewing the log files within your container, Docker logs, and then the container ID. So it's a very simple system to get started with. So let's create a basic little container. Obviously we're at PyCon, so I've got a nice Python one here. So for 2.7, we go a docker run -t-i python :2.7. And for 3.4, we simply just specify the version. So how this actually works. -t essentially means terminal, and -i makes it interactive. It means we can type and use it. And I must apologise for some of these. I've had to take videos of the demos I was going to give. My original MacBook decided to die 2 days before this event. And lastly, we specify the image and a tag. So generally the tags are used as versioning. So if we run a quick little demo, just docker run -t-i Python 2.7. And you can see we're straight into a Python shell and we can get started straight away. And again, to run a 3.4 shell, this installs and creates a container in the background and installs Python in it. So let's just look at a little simple app. I have a 2-line of Python, because Python's nice and simple. And basically all we're going to do is say, hello PyCon Australia, and spit out the version number. So to turn my Python file into a Docker container, there's 2 steps I need to do. The first of that is to create a Dockerfile. So a Dockerfile is a very simple text-driven configuration file that essentially you need to specify everything that it needs to do to start and create the image. So for this one, because Docker gives us the layered ability, I just start with a Python 2.7 image already. I copy my hello PyCon file just into the root directory, and finally I run the command python hello pycon.py. So now that we've created the Docker file, the next step we have to do is build the image. For this, doing it locally, we're just going to specify a tag with the -t, just so we have an image to reference. And we specify that it's in that directory. So literally in that directory was just the Docker file and the hello PyCon file. Once it's built, then all we need to do is docker run pycon-au /hello. And there should have been the example of it actually running. So to give a quick Flask example, this is sort of more like what it'll be used in a real world or in a production environment. So again, it's a simple command structure, except this time we're going to set it to run as a daemon. Then we're going to use -p to map port 80 to port 5000. So essentially port 80 will be on the host and it will map that to the container on port 5000. And we're using the Docker's training web app for this. So just to see it run. For this one, I didn't actually pull in the images, just so you could see the process run from scratch. Unfortunately, I ran it at home on my Optus cable connection and managed to pick their peak time to do it. So it was unable to find a copy of the training app locally. And as you can see, it's going and downloading automatically all the layers that it needs to run this application. This particular one is an Ubuntu-based image, so it's downloading the multiple different layers for that as well. The good thing about Docker is once you've pulled this in, if I had all of those layers except for the last one, all it would need to download is that last layer. So if we just skip through, it quickly extracts that. Because it's a copy-on-write overlay file system, it takes care of all that work in the background for you and starts up the application. So of course, we can then go to a web browser and see our magical Hello World application. We can also have a look at the log files. So again, if you're used to running Flask or similar systems, you can see the log output from that container. The Docker file for this one. So this one was a little bit more complex than my simple example, but just to run through it quickly, they used an Ubuntu image, they came through, grabbed python-au, installed pip, installed the requirements, copied the requirements over, installed the requirements, exposed port 5000, so this allowed the host container to map a connection to it, and we ran our application. And just for completeness, that was the Flask app that it ran. So you can see the port 5000, this is where it came into it. So the ports that it starts up in your application here, that's what you need to expose to have the ability to access it from a host or from an external source. So the good thing about Docker is it comes with everything, including the kitchen sink. Once you start to get into more complex Docker scenarios, and when you're running multiple containers, they have Docker Compose. So Docker Compose gives you controls for multi-container deployments. It's a very simple YAML-based format, and again, like everything Docker, it reduces everything down to a single command line to run. Docker Swarm, this is their clustering component. So this is where they're trying to work on and simplify the host level deployment. It's currently still in beta, so there's quite a bit of flux in terms of how it works and the feature sets that it has. Docker Machine, again, Docker wants to make everything easy for you. So Docker Machine that will create the host for you. So this can directly interact with AWS and actually spin up the instances for you, as well as a number of other cloud providers. So where's Docker going in the future? Obviously, it's a rapidly growing technology, but two of the next bits that it's working on to push out is a volume plugin, which has now made it into the mainline code, but it gives you pluggable storage. So by this, it can interface with systems like, currently they've got the demos for NFS, EMC filers, Gluster, and similar. So you can have your data stored in an external source and reference from within the container. They're working on a new network system. So obviously the current one works well for simple host environments, but it doesn't work well when you get to a bigger scale. So they're using VXLAN essentially to be able to bridge between the multiple different hosts, and they're turning it into a services-based model. So rather than specifying ports, you'll be able to specify networks, specify services. So in conclusion, go try it. No, really, go try Docker. It's quite simple to get started. It allows you to embrace the microservices philosophy and enjoy pushes to production. Because your dev environment running containers, running Docker containers, is exactly the same as your production environment, you eliminate all those hassles in between. Okay, if you want further reading, I've got my slides up here and also linked a number of tutorials that I've written. There was also a really good presentation at PyCon this year that gave a good overview of Docker. And of course, the official Docker documentation itself. And with that, we got any questions?
Hi, you said Docker locally caches container images. Is there a way of caching images on your network for multiple hosts?
Not that I know of. I haven't actually sort of delved into that, so there may be a tool actually available for that. But it allows an easy just Docker pull to pull that all the data down per container, or per host, sorry.
Hi, thanks for the talk. I briefly played with Docker like a year ago and haven't actually touched it since. Two questions. One is, so at my work we're using SaltStack for our configuration management, which I could be using Ruby or Chef or Ansible or the other alternatives. How do the two play in together? Because you look at the Docker files and it's like, oh, now we're going back to a bash script. Any tips on how you get those two working well together? And my second question is that I'm using Vagrant for our dev builds. If I start using Docker, do I just throw that away and spin up a Docker image or whatever the terminology is? Yeah,
no, good question. So the SaltStack has actually integrated a Docker module. So SaltStack itself can now talk natively to your Docker instances. I haven't played with that. I've just seen it available, so I'm not sure exactly how that component works. In terms of Vagrant, I was using Vagrant, and now I'm just using Docker containers. So essentially, I've got my using Docker Compose, and I spin up the multiple different containers, everything running, ready to develop. Absolutely, yeah. Yeah, if I've got all the layers in there, I can spin up my development environment within a few seconds.
All right, we've only got time for one more.
Hi, great talk, thank you. Is Docker viable as a sandbox for running untrusted code? What do you have to do to it, or is that the wrong approach to go completely?
Absolutely. In fact, a couple of people have demoed a number of instances. All the one-liner scripts that you see out in the web to install a service, like, you know, when you normally see, you know, pipe this curl command into bash and run it. Anybody that's security conscious, of course, wants to figure out what exactly that script is doing. Docker actually have a docker diff command. So you can do it against a standard container, run that curl script, like download it, run it, and it'll actually then give you an output of what files have changed and where they've changed. So you can use it for that sandbox testing as well.
So I'm sure people can approach you with at afternoon tea with their questions.
Absolutely, and I've got, Docker kindly sent me some shirts and bits and pieces, so I'll put some of them out on the table, but come see me, yeah, and get some Docker swag.
One more round of applause for Tim.